Hey everybody, and welcome to this 1202 lesson. Today we're getting out of the nitty-gritty systems and features stuff and we're going straight into 1.7. Given a scenario, configure Microsoft Windows networking features on a client/desktop. Some more kind of broad conceptual stuff here, a lot easier to talk through, but still important stuff to understand. So buckle up, I'm going to tell you every single thing you need to know about this, just like I always do, and I'm going to give you practice questions at the end, just like I always do. So let's go ahead and start with domain joined versus work group setups. What does that mean? Let's go ahead and get to it. First, if you're new here, my name is Matt. I help people pass their A+, 1201, 1202, 1101, 1102 examinations. People are saying my notes help them pass. This person got full marks and is now moving on to Network Plus. This person passed just a few moments ago and is thanking me for their help. This person passed their A+ as well. So if you want to be like them, subscribe, like, comment, follow along. I got you. Don't worry about it. Now, domain joined environment. What does that mean? So this is where we've got to buckle up and focus up. A domain joined environment is essentially an environment where it's leveraging Microsoft's Active Directory for centralized management. And that's going to be the key, centralized management. If we have a look over here, right, we've got this thing. You know what? I'm actually going to draw a picture because I think it works a little better. So a domain, essentially, right, I've got this central method of managing everything. And along the sides, I've got a device here, 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 device here. All these devices are linked to the central management system, right? So if I were an IT professional in charge of managing these systems, I could do it all from one place. Functionally, that's what we need to understand about the domain, right? That's the key thing about the domain. It is centrally managed. So all users, computers, and resources are part of a single unified security database. It is highly scalable. You can just add devices to that pretty effectively, pretty efficiently, okay? It offers robust security with single sign-on capabilities, and it provides streamlined administration across the entire network. So you can organize everything from one spot. It is centrally manageable, and that is different to a work group environment. So that is a decentralized peer-to-peer network architecture. Now let's talk about what that means, right? We said how this is, this was the first one we talked about, which was domain. Now this one, peer-to-peer or work group, it's kind of like I've got one over here. This one's Jim's computer, this one's Bob's computer, this one's Matt's computer, and this one's Rachel's computer, okay? Now, I'm going to have to come in and set up this computer. Then I'll have to walk over here and set up this computer. I'll have to walk over here, set up this computer, etc. If I want to send something from this computer to this computer, I'm going to have to come over to this computer, log in, set up my profile, and physically send that file over. I'll have to enable sharing, enable access physically in order to let this computer access it, okay? So with a work group, you are setting up each individual computer and you're just linking them so that they can talk to each other. Whereas with the one we just talked about, with the domain, instead, what you could do is you could come into the central management database system. You could use Active Directory to centrally manage everything. You could say, you know what? You all immediately have access to this file and you can all access it and share with each other through the central database. You don't have to individually go to each computer. You do everything from that central management system. That's the key fundamental difference between the two. Okay, that's the fundamental difference that we need to know about. All right. Now, that being said, your individual user accounts and resources, so you have to make an account for every single device, suitable for small networks. So if you got a few computers in a home network, very small network, you'd want to go this because it's less expensive, but it's not scalable, all right? The second you get to need a lot of scale, you're going to need to go with a domain, all right? So shared resources in a domain environment, again, it's all shared centrally. It's seamless user authentication. Single sign-on means you don't have to log on over and over again. Resources are easily discoverable and shared. But in a work group, you have to manually share resources among devices, all right? You're going to have to individually authenticate to each resource, and it can become very cumbersome to manage and discover those resources. So again, with printers in a domain environment, you can have a printer deployed centrally through dedicated print servers, which means everyone can easily access that same printer. But in a workgroup environment, printers are shared directly from individual PCs. So users must manually connect to each shared printer, all right? Driver installation is required independently on each machine. Basically, you've got to individually set it up on each machine in a work group. But if we go back to a domain, you can just get a print server set up so everyone can easily access that. So it's all about how easy it is to access. If you've got a big environment, you're going to want a domain to centrally access and manage everything. If you've only got a few computers, a work group is going to be okay, but it's going to be a little bit more tedious. All right. File servers, again, same thing. In a domain, you can have dedicated, centrally located file servers that everyone can access. But in a work group, file sharing relies on shared folders on those individual computers. All right. So those permissions are managed locally on each sharing machine. So your mapped drives, again, in a domain environment, you can automatically configure through group policy objects. You can deploy them to users' computers at logon. You can ensure consistent access to network shares. Automatic deployment capabilities eliminate manual setup. Again, another key feature is in a domain environment, because it's centrally managed, everything can be just kind of pushed out to all devices at once. So you can automatically map devices to network share drives, for example, centrally very easily. But in a work group environment, you're going to have to manually configure on every single computer. Right? So that principle is carrying across all of these areas. It's simple, unmanaged scripts may be used sometimes, but generally, again, you don't have that centralized deployment capability where you can just push it out. You're going to have to sit down and log on to every computer and manually map it on every computer. So there is higher administrative overhead for that purpose, all right? Now, that's the difference. So before we move on, let's just recap that really quick, because I don't want to move on if we've struggled to understand that. Let's just really focus up on that. Oh, that's terrible writing. Domain is this one, right? Where everything is centrally managed. Functionally, that's what you need to understand. Workgroup is individual machines. Should I even try to write this? I'm not even going to try. Workgroup is individual machines, individually managed, talking to each other. But a domain is centrally managed enterprise level environment. All right. Functionally, that's what you need to know. And we've just talked about some of those specifics there, how that works, or what you need to know for your exam, what they've said you need to know. Now, the next one is your local OS firewall settings. So we need to understand local OS firewall settings, how that works. So application restriction. All right. You can control what applications can send or receive network data. Maybe you want your workers to be able to use Microsoft Teams, but not to be able to use Steam to play Call of Duty Warzone during work hours. You can default block applications, especially incoming connections. You can have explicit restriction of potentially malicious programs. Basically, you can say what applications can or cannot run or communicate, okay? And you have granular management of network access permissions. So you can get very specific. You can also make exceptions. So you can create something called allow rules. Basically, in your firewall, what you would do, right? I didn't get time to change this AI generated image. Forgive me for that. This one was a little bit rushed. I kind of make these at work so that I can deliver the main principles and concepts to you after work. So we're working with what we got, but I'm going to tell you what you need to know functionally. So an allow rule is basically when you might say, I'm going to deny everything, but I'm going to only create allow rules for what I want to be allowed to operate on the network. Right? Or what the applications I know I need to function. This is very high security because the only applications that are allowed to communicate are the ones that you need. Everything else is by default not allowed to communicate. So you might say deny for everything, but I'm going to create an allow rule for my legitimate applications. So for example, I might create an allow rule really for anything that I need to be able to operate. And I can get really granular with specific ports and protocols. So I can say, I'm going to create an allow rule for port 25 because I need protocol SMTP to be able to send mail, for example. Network type restrictions. So if you set your network to public, it's going to be a lot more restrictive. Private is going to have more trust because it's going to say, hey, you're in your own private network. And you can also have different domain profiles where they're individually set up restrictions there as well. So basically, you can use your application exceptions or allow or deny rules to balance between your necessary functionality and security to make sure you allow what needs to communicate, and you block what doesn't, so that you only have communicating what needs to communicate. Hopefully that made sense. Functionally, if you kind of understand what I said, that's what you need to know. Don't get too in the weeds with it. That's what you need to know. Accessing your firewall settings. So you can go to network and internet, privacy and security, Windows security, firewall and network protection. So let's actually go ahead and do that now. Let's go to network and internet, or should I just go, why don't I just go firewall? Here we go. So I can just open that up, full screener, and here, right, I can start to have a look at my inbound rules. So if you have a look here, you can actually see what is enabled and what is not enabled, what protocol it uses, the local port, etc. So if I wanted to create a new inbound rule for data coming in, I could click on new rule over here. Here, I'm going to say, is it based on a program? Is it based on a port? Is it predefined or is it custom? Let's say it's based on a port, for example's sake. I click on next. I'm going to say, all right, this is going to be TCP. The specific port is going to be port 25. And I'm going to go ahead and allow that connection, right? So you can see here, you can set those rules. Same for outbound rules. You can do the same for an outbound rule. You can say what you do or don't want to communicate. All right. So you can kind of see what I mean there by setting those rules. All right. So I've just showed you how you can access that, but you're going to have to play around with that. I was just using the MMC snap in there. All right. I was just using that. Okay. Now, before we move on, just understand the concept for firewalls, that you can have specific rules for allowing applications or ports and denying or blocking applications or ports based on what you want. That's what you need to know, okay? Network profiles. So you have different network profiles. If you set your network profile to public, that means it is going to have very restrictive security settings because it's going to assume you're on a public network. If you're on a public network, anyone can really look at your data and see what you're sending. So it's going to be very restrictive. But if you have it set to private, it's going to think, hey, you know what? We can actually allow a little bit more data. Sorry, not data. We can allow a little bit more leniency here because we're on a trusted private network. So it will be more permissive for trusted home/office networks. Additionally, there's a third one, which is a domain profile. So this is optimized for corporate domain environments. So it has automatic application based on the network type detected. Different security contexts require appropriate rules and context-aware protection for various network scenarios. Basically, what that means is you've got these two basic ones, and then the domain profile, right, customized based on that individual domain, depending on what your particular setup is. But just understand the concept. Public is more restrictive, private is less restrictive. Functionally, that's what you need to know, okay? Custom rule creation. I've just actually gone through this, right? I just showed you creating those inbound rules and outbound rules based on program, port, or protocol. I've just showed you what that looks like and explained that to you. So I'm not gonna harp on too much more about that. Client network configuration is another thing we need to know about. So your essential settings that enable computers to communicate on local networks and access external networks such as the internet, dictating device identification and traffic routing. Let's have a look at what you need to know for your exam. I'm trying to keep this as fast-paced as possible. By now, we should be familiar with the Internet Protocol Addressing Scheme, particularly if you've done your Core 1, which I assume you have. Maybe you did it with me, in which case, good job on passing. I knew you could do it. Quick recap, right? IP protocols, you've got your IPv4, which is 4 numbers separated by a dot, and then you've got your IPv6, which is numbers and letters separated by colon, okay? What do these do? They enable devices to communicate with each other and to identify one another. They are the foundation for all network communication. You should know this by now from your Core 1, assuming you did that first. So we should know what an IP address is, right? So specifically, we do need to go a little bit more in depth and know what a subnet mask is. So a subnet mask is something that we apply to an IP address to tell us what portion is the host and what portion is the network. If that's confusing, it's okay. I'll tell you what I mean in a second, right? So let's say I have an IP address that is 12.4.67. 220, just for example's sake. That is my IP address, okay? Now, part of this address, just ignore this for the second, part of this address is the network that the actual device is on, and part of this address is the specific number that tells me, like, what is the address of that device within the network. So for example, it could be that the network is 12.4.67 and the device portion identifier is 220. So there might be another device on here that's 12.4.67.219 and one that's 0.218, right? Or it could be that the network is 12.4 and the device identifier is 67.220, right? You see what I'm saying? So we need a way to figure out which portion is the network and which portion is the device. We do that with a subnet mask. So a subnet mask generally is going to have the numbers 255, and it's either going to be 1, 2, 3, or 4 of those. So it might be 255.255.255.0. And what this does is it correlates with this number, the IP address here. So wherever there is an IP, there is a 255 underneath that number, that's going to tell us that this is actually the network. So let's do this in action. Let's kind of separate this. So 12, is there a 255 underneath? Yes. So that means the 12 is part of the network, not the host. 4, this 4 is the second number. Is there a 255 in the subnet mask? Yes. So that is also part of the network. 67 is the third number. 1, 2, 3. Is this also 255? Yes. Okay. 220 is the fourth number. Is there a 255 for the fourth number in the subnet mask? No. Okay, so that tells us that everything to the left of 220 is the network and everything to the right is the device. So the network we know is 12.4.67.0 and the device identifier is 220. That's what a subnet mask allows us to do, essentially. Hopefully that made sense. Might need to revise that one if it didn't, but hopefully that made sense. Okay, so the default gateway is just where you're sending your data in order for it to access the World Wide Web, the wide area network outside of your LAN. So every computer has a default gateway. That's basically saying, hey, where am I sending my data to in order for that data to leave the local area network? That's all that means. So it's the IP address of the router acting as network entry/exit point. During our Windows commands that we did, we looked at finding our default gateway using command prompt tools. And we said, if we type in ipconfig, we can actually see our default gateway. See here, it says default gateway is here. That is the IP of my router, essentially, right? So that's the default gateway. We also have domain name system settings, DNS settings. So that is the IP address of servers translating your domain names to IP addresses. They convert. We know what DNS settings, we know what DNS servers do at this point, right? By this point in our studies, hopefully we know that DNS servers do in fact convert IP addresses to URL and URL to IP addresses. They're crucial for accessing websites. We know what they do, all right? We know what DNS settings, what DNS servers are. So we need to know something specific about IP addressing, and we need to know when we would use a static IP address. So an IP address is when a static IP address is when you manually enter that. So it is manually entered on the machine itself. It is never going to change. You're not doing it on a DHCP server, you're doing it manually. Why would you do that? Because maybe it's a printer and you want that IP address to always stay the same so that every device on that network knows exactly how to access that printer, all right? So you would manually configure the IP address as a static IP address if you had something where you want the IP address to always be the same. Dynamic, the DHCP server is automatically providing you with an IP address when you join the network, all right? That is generally most of your bring your own devices, things that you're bringing to the office are going to be giving a an IP address this way. Now, you need to know about establishing network connections as well. So your virtual private network, basically a VPN, is a secure encrypted tunnel that you can use to communicate securely over public networks, right? It encrypts your data. So even if someone captures your data, they're not going to be able to read it. It enhances your online privacy, and you can bypass geo restrictions, which means if you live in America and you want to watch UK Netflix, you can set your VPN to say, hey, just tell them I'm from UK, and you can get all that UK-based Netflix, for example. It also hides your IP address from internet service providers and third parties too. So if you want that increased privacy, a VPN is something that you're going to want to use. How do you configure your VPN? Once you install it, it'll pretty much run you through that process, really. You're not going to need to know the details of this. You just functionally need to know that a VPN encrypts your data and can do everything we just talked about. When you download it, it will run you through the process of configuring it, all right? Now, Wi-Fi connections, we know what Wi-Fi is, guys. You don't need me to walk you through this. What we do need to know is that every router for Wi-Fi or wireless access point for Wi-Fi is going to have an SSID, and that's just the name of the network that you see when you join it, right? My SSID of my router is Damad's house. It's a family inside joke reference. I've personally set it. I've changed the default name. So that is my SSID. That's the Wi-Fi name. Right? You click on that, put in the password, that's how you join the network. All right. I'm sure we've all joined Wi-Fi before. Okay, wired network, you plug in your Ethernet cable, that's about it. Wired configuration, you just plug it in, it will configure for you, and you'll be good to go. You probably don't need me to walk you through that really. Wireless wide area network, going back to the core one a little bit here again, some similar content, but it's basically providing cellular data to you over a wide area. All right. So if you have highly mobile devices in remote locations where there's not a lot of other internet access methods, this is a potential way you could get access to data so that you can use the internet in a remote location through a wireless wide area network. All right. How do you configure a WAN? You'll generally, a WWAN, you will need a device with a built-in cellular modem. You'll need an active SIM card with data plan from a mobile carrier, and then you'll be able to access that essentially. Proxy settings. So a proxy server, right? What is a proxy server? Let's get into it. How does a proxy server work? First things first, a proxy server, if you have yourself over here, oh my gosh, you're so big. You have yourself there, and you want to talk to this guy over here, but you don't want him knowing who you are. So what you do is you use a proxy server. So your IP address, you might have an IP address here, but you don't want him to know what your IP address is. So you send your data to a proxy server, and this guy, the legend that he is, will actually say, hey, I'm going to send your data on your behalf. So now this guy is going to see my IP address. So he is not going to know your IP address. It is going to be hidden. So the recipient will see that this data came from the IP address of the proxy server, not from the IP address of the actual sender. All right, so he will not know your IP address. So it gives that level of extra security and safety there. So that's roughly what a proxy server is. How does it work? It sends requests to the proxy server first. So you send your request to the proxy server. We just went over that. It processes your request and adds its own IP address and forwards that request using its own IP address. So it will then come back through the proxy server and then come to you. So it is an intermediary for all web traffic. It adds security and filtering benefits. So your content filtering blocks malicious and inappropriate websites. Proxy servers can do that. It can enforce organizational internet usage policies as well. It can check that you're doing the right thing before it sends or receives data. It can hide internal network structures from the public internet. It has enhanced security through traffic inspection, protection against direct external network attacks, and centralized logging and monitoring capabilities. It can log all the data that's coming and going to through it either direction. All right, so it can do a lot of stuff other than just masking your IP address. It can also cache data for additional performance, which is basically where what's happening is it says, oh, hey, you're accessing this data a lot, and you're having to go all the way over here to the World Wide Web in order to do that. Instead, why don't I just take that data and store that here, so you only have to come this far to get it, and it'll be way faster. All right, so that's another thing proxy servers can in fact do, and that's pretty neat, pretty handy. So it has that benefit, and of course the privacy benefit, which we've already discussed there as well. So, and again, it can monitor, it can audit traffic that goes through if it is configured to do so as well. Now, we've talked about public versus private networks already briefly, so I'm not going to go on too much about this, but just a quick recap of what we discussed at the beginning. Public network is an untrusted network. So maybe you're at a cafe, anyone can capture and read your data there. So if you set your network profile to public, your device will treat it as an untrusted network and be much more restrictive. Generally, you want to use a VPN here to be safe, but if you can't, a public network classification is the best you can do to make sure your device is being pretty stingy with what it allows. Whereas, so there's some examples, right? Basically, it's more restrictive in a public network setting. However, yeah, we get the picture, right? Private network it's going to assume you're on your own home, right? You're in your home or you're in a private trusted network, so it will become less restrictive. Functionally, that is what you need to know. Really, functionally, that's it, okay? It's more willing to relax some security restrictions for increased functionality, all right? Largely, that is what you need to understand. Public is more restrictive, it's not safe. Private is less restrictive and is considered safe. That's it. File Explorer navigation, your network paths. So you need to know something called UNC or Universal Naming Convention for network paths. So the UNC is a standardized format beginning with 2 backslashes. So basically, it looks like this, right? // it's the name of the server / share name. So if you want to access a network share, you would use this kind of syntax. And functionally, what you're going to need to know is when you see something that looks like this, you need to be able to say, hey, this is a UNC for a network share. This is not an IPv4 or IPv6 or MAC address, all right? Functionally, that's what you'll need to know. So the server name can be a computer name or an IP address. The share name is the specific shared folder or resource, okay? So just understand, this is the naming convention for accessing shared servers from your device, okay? This is the syntax that you will need to use, okay? Direct navigation methods, you can type that full path into File Explorer to access and connect to the specific network share. Or you can use the network section in File Explorer, list discovered computers and devices on your local network, and then you'll browse through the computers to see the available shares. When you select the specific computer to view the shared resources, you can navigate into shares like they are a local folder, but you'll require network discovery to be enabled. So basically you can do that, or you can type the full path into your Explorer, File Explorer there, all right? If you want to map the network drive, you can actually assign this permanently to a drive letter. And we remember the command we talked about in Learning Objective 1.5, which allows you to map a network drive or network share to a drive letter, right? We did talk about that. You might want to go back and revise that one, but basically you can make this like a local drive by mapping it to a drive letter on your actual device, which will kind of automate this process every time. You just click on that drive and you'll go straight to the share. All right. So in order for this to work, your computer has to be connected to the same network. It has to be able to route traffic between different networks if it is not on the same network. Your file and printer sharing must be enabled on your target computer, and specific folders have to be configured as network shares, right? You also have to have the appropriate permissions, and your user authentication credentials need to be there, right? All right. Metered connections and limitations. What does this mean? Metered connection is basically where you're saying, hey, I only want to use this much data. If I go above this much data, stop. Just stop letting me use data. I don't want to use any more than this. Why would you want to do that? Maybe because you don't want to spend money. You have a data cap. If you go over that cap, you're going to have an additional charge, or you don't want to use any more than that amount of data for the day. That's basically what a metered connection is. What are the good? What are the bad about this? Let's have a look. Metered connection identification, right? You can, essentially what I just said, you can set yourself to have a metered connection. So if you want to set a metered connection, you can go to settings, network and internet, and then Wi-Fi/Ethernet, and you can toggle set as metered connection. And that would basically set that. You can set the details there. All right. So the limitations of this is it might hinder Windows updates. It might hinder app data. It might stop OneDrive syncing, Microsoft Store, offline files, and system priority, perhaps essential traffic prioritized will be prioritized over background activities. So you got to be careful because Windows updates require data, right? So if you've got a metered connection going and you've run out of data, you're not going to get those Windows updates. So you could just be careful on that, right? Read that, take that into consideration. Now, that's everything we need to know functionally. So long as you understand most of that or all of that at a base level, you'll be all right. Let's go ahead and do some practice questions to see how you are tracking. Question 1 reads, an IT department is setting up a new office network for a large company. They need a network environment that allows for centralized management of all user accounts, shared resources, and security policies. Which type of network environment is best suited for this purpose? Is it A, workgroup, B, domain, C, peer-to-peer, or D, home group? I'm going to take a sip. By the time I'm done, I'm going to go to the answer. Pause the video if you need more time. All right, here we go. It is B, domain. Remember, guys, domain is that central management. Workgroup is individual, decentralized devices manually, individually being configured. So if you're in an enterprise environment that needs any kind of central management, the answer is domain. If it's a small office setup where computers are individually managed with no central management, it's a work group or peer-to-peer. That's another way to say the same thing, work group, peer-to-peer. Okay, next question is, a user in a work group environment wants to share a folder with a coworker. Where would they configure the permissions for this shared folder? A, the group policy management console. B, the Active Directory users and computers console. C, the local security settings of the sharing computer. Or D, the network routers configuration page. Your answer coming in 3, 2, pause the video if you need more time. 1, here we go. It is C, the local security settings of the sharing computer. Group policy does not exist outside of a domain. Active Directory is used in a domain. The network router has nothing to do with the sharing permissions of that individual computer. You would have to use the local security settings of the sharing computer. All right, that's how you would have to do it. Now, the next question is, a small team of designers needs to collaborate on a few large files. They are working on a simple decentralized network where each computer is a standalone unit. Which type of network environment are they using? A, domain, B, client server, C, wide area network, or D, work group. Hopefully by now you've got this one. Let's go straight to the answer. The answer is D, work group. It is decentralized, therefore it is a work group. That's the giveaway. All right, let's move on from that. The next question reads, a technician needs to configure the local OS firewall with very granular advanced control over inbound and outbound rules, including specific ports and protocols. Which tool provides the most comprehensive interface for this? A, the Windows Defender Firewall applet in the control panel. B, the standard Windows settings app. C, the Windows Defender Firewall with Advanced Security MMC snap-in, or D, the NetStat command line utility. Your answer coming in 3, in 2. Pause the video if you need more time. In 1, let's go. It is C. You're going to get the most advanced control in the MMC snap-in. That's one I was showing you guys where I was setting those inbound and outbound rules. All right. So again, some of this content, I'm kind of quickly going through it in the video. All of this is detailed, covered in the learning guide. I'm kind of giving you the broad overview in these videos. So the chances that you can pass with these videos are so high. There's some chances maybe where the learning guide is going to actually have that additional information you require. This might have been one of those questions where I didn't physically say it in the video here, but it was on the slide and it is in the learning guide. All right. So the next question reads, a system administrator wants to restrict a specific application from communicating with any external network. Which type of firewall rule would they create for this purpose? A, an outbound rule to block the application's traffic. B, an inbound rule to block the application's traffic. C, a public network profile rule. Or D, a rule that only blocks specific IP addresses. Pause the video if you need more time. Your answer is coming in 3, in 2, in 1. Hopefully we got this. It is A, an outbound rule. If you're trying to stop an application from communicating with an outside anything, you'd set an outbound rule because you're saying what data cannot leave your network, what data cannot go out from your network. An inbound would be if you want to create a rule about data that can come in. All right. But in this specific circumstance, we were saying we want to stop the application from communicating with something out there. So an outbound rule would be the most correct answer. Wow, I'm giving you a lot of questions in this one, and I'm starting to regret it, guys, because I'm losing my voice. Then this question reads, a technician is configuring a new computer and wants the IP address to be automatically assigned by a server. Simplifying network administration. Which type of IP addressing should they use? Is it A, static IP addressing, B, dynamic IP addressing, C, IPv6 addressing, or D, up HIPAA? Pause the video if you need more time. Your answer is coming in 3, 2, 1. Of course, it is B, dynamic IP addressing. All right, if you want something to be automatically assigned by a server, that is going to be dynamic IP addressing. The DHCP server will automatically assign you an IP address. Answer A, static IP addressing, is for things that are static, right? A printer is always going to need the same IP address. Devices are always going to need to know what that IP address is. So something that always needs to be the same is static, manually configured on the device. Something that can get a new IP address every time it joins, automatically given by the server, will be, of course, dynamic IP addressing. All right. We're going to skip that one. I've done too many of those. Yeah, good. We're at the end. Thank God. I really needed that. So, guys, if you've enjoyed this and you want to pass your exam, just like I've helped these people pass, have a look at this one. Have a look at this guy pass. This person saying my learning guide is goated. Organized information really helps. This person pieced information together more easily. This person immediately saw my learning guide would help them as soon as they downloaded it. This person passed with my notes and learning guide. This person got almost full marks and is moving on to their Network Plus now. This person passed their A+ Core 1. This person, that's it. But look, essentially, guys, with my learning guide, you get detailed notes and practice questions broken down by exam objective. So you get notes followed by practice questions for exam objective 1, and then the same thing for 1.2, and then for 1.3, broken down. And once you've systematically gone through all of that, you then get your 3 practice exams that are randomized with performance-based questions in there as well. Okay, you get videos telling you how to study with multiple choice questions, so you actually are ready for your exam and you're not just floundering about. You actually know how to study. You get videos showing you very specific study techniques using AI tools, and videos showing you how to go about answering multiple choice questions if you're not sure what the answer is. Okay, that's all at journeytocyber.com/1202. The link is in the description below and in the comment below. Go ahead and click that if you want to get your hands on that. Otherwise, I'll see you in the next video, guys. Bye.